explain. I'm Rishikesh, and we'll be discussing something about a small brainchild of an idea called Covert Wireless Network, and we named it as a DARWIN. So, what exactly is a kind of flow for this whole talk, we can say? So, introduction and some details, covert communication, information element approach, Darwin functional details, work in progress, ACK and questions. Slides are a little messed up, so my apologies in advance for that. So yes, in 2014, basically when I was more into consulting part, I was questioned by many of my clients, like why we always need a set of intrusion detection systems, prevention systems, or something like that in order to defend against a specific attack. Isn't there any other way out? That was a question. And yes, that question is still valid, but I tried cross-questioning that particular approach and thought of why not hide all of the traffic from adversary instead of uh, keeping on defending that offensive traffic instead. So that was a motive, honestly, and slowly we started understanding a lot of details into IEEE 802.11 protocol specification, around 6,000 pages documents, maybe more now. And yes, while doing that, we came to know there are many fields, or rather, there are many frames which are speaking on data link layer, obviously. Some of these frames are meant to ship data over it, and some of them are meant to just kind of broadcast something having no data inside them. So basically there was no payload in many of the frames. So Darwin, we can kind of build out of these three building blocks: covert traffic scripts, push and pop messages from command line, and transceiver. So before touching to the core functions of Darwin, we just need to understand a bit of working of wireless networks on some modes, we can say. Rahul, can you just show that device? Just hold it up. Many of you would have seen this particular device called Alpha Network Card, right? Most of us who are in security practices, they use this device to do something messy on wireless networks, right? Like that, a miniaturized device is present in our laptop as well. Okay, so all such devices which allows our machine or our device, our laptop or desktop to speak somebody or some other machine using wireless as a medium, we call them as a wireless network interface card. Now these wireless network interface card has got a different behavioral traits. So in this quadrant, you can see those 4 different behavioral traits. One is managed mode, another is ad hoc mode, third is master mode, and fourth is monitor mode. Just to save on time, I will not speak on rest of the 3. Let's talk about monitor mode. The fact is, even our routers or other access points runs in monitor mode, or at least some of the protocol analyzers tells us that. Okay, now what exactly is a monitor mode? How many of you have actually used Wireshark on wired networks by any chance? Okay, do you want me explain what exactly is a promiscuous mode on wired networks? Or it is known to you? Known to, okay, perfect. So analogous to promiscuous mode on wired network, we have got monitor mode on wireless network. In fact, monitor mode on wireless network gives us a lot of power per se. So what kind of power it actually instills in an attacker or a defender is, it allows you injecting whatever frame you want into the local radio periphery. Same time, it allows you receiving whatever frame you want, even if that is not addressed to you, in the local radio periphery. So covert communication, some bookish definition, forgive me for this, but has to be mentioned. In computer security, a covert channel is a type of computer security attack that creates a capability to transfer information objects between processes that are not supposed to be allowed to communicate by the computer security policy. Even if you don't pay any attention, I'm fine with this definition, no problem. Yes, because most of the times, honestly, my experience is whatever author tries to tell you in some legitimate technical book, for me, that is actually, he is trying to divert us from some core chunk of knowledge. So is the reason, even if you don't pay attention to that definition, fine. Information elements approach. So information elements approach is where we tried basically inject certain data into some broadcast frames which otherwise were not having payload as a part of their frame. So there have always been ways to smuggle data. I've just explained you these things, so that's fine. And yes, the last line, and that too specifically on broadcast frames. Why? We'll come to that question later. Before going ahead, we just need to again understand few flavors of frames. There are like data frames, there are a couple of more flavors as well, and management frames. In management frames, whatever the frames that we see here, out of almost 1, 2, 3, 3 types from bottom to top are actually broadcast frames. Beacon, probe, request, and probe response. These are the three frames which are broadcast frames. Is there anybody, someone who don't know the meaning of broadcast? If it is there, broadcast is nothing but the way of communication when one person is trying to send something to everybody. Fine with that? Okay. One more thing we need to know going ahead, SCAPI. SCAPI is basically, we can say, a boon given by Python. Purposely I'm calling it boon because it can be used as a tool, can be used as a library, can be used as a specific set of methods, could be anything, right? So SCAPI is again packet manipulation, frame manipulation, tool and program as well, allows forging and crafting packets and frames. So now you would be able to connect the dots now, like the way I'm trying to give you insights on certain pieces, now you would be able to tailor them together and go ahead with this. So yes, supports various protocols. Yes, SCAPI is not only for wireless. We can use SCAPI on wired network as well. For various protocols it supports. Nowadays they have got a new module, something called as a radio SCAPI, which actually allows you messing up onto certain protocols which are supported by SDR. Yes, probably in work in progress I'll be having something to tell on this. So for SCAPI, wireless frames are just a set of layers and sublayers. Okay. Is this readable on screen? Okay. I'll share I'll share these slides with you guys. I don't know. Okay, just bear with me. This is actually a set of layers. In order to represent a particular wireless frame, what kind of layers we are supposed to lay in SCAPI? This is that particular representation. Is this readable? Perfecto. This is required. That doesn't really matter if you could not read previous slide. This is something, whatever those blocks were there, the actual representation of those blocks, how we actually represent those blocks in SCAPI as a script is this. So on all of these parameters we'll come one by one. Okay, as of now, whatever that is separated by a slash is nothing but layer. Fair enough? Everybody's with me? Somebody want to doze? Okay. I know it's pretty late and everybody is in party mood. I would try to least torture you guys, don't worry. So beacon frame in again a formal context. So there's a lot of information stuffed inside wireless frames. Actually, wireless frame in itself has got a lot of different, we can say, segments. For example, frame control sequence has got somewhere around 65 sub elements. Okay, I'm giving you just an example. I'm not trying to kind of scare you guys or something. Everything is interesting in wireless. I have been learning this since 2009. I'm reading, not learning, honestly, and I still am not confident if I know 1%. So that huge it is. Enjoy it. Yeah. Perfect. So interesting elements are like SSID stands for Service Set Identifier. Yes, one more thing. In this talk, I'm trying to avoid definitions, as most of us are using wireless network on day-to-day basis, right? All of us know what exactly is name of wireless network. That is nothing but SSID, Service Set Identifier. What is access point? Some device which actually gives you internet on wireless medium. Perfect. So these are basic definitions I've tried cut down on. So SSID, DS set, TIM, traffic indication map, rates, ES rates, TPC, request and response, country. Now you would be questioning what exactly all these names are. Here it is. Again, this would not be readable. Is it? Is it readable or semi-readable something? Yeah. So while actually understanding function of every of the element in wireless frame, I had browsed through these particular 6,500 pages many a times. And one time, accidentally, actually just like 2 hours before my talk in BrewCon, I came across this table. Till then, I was actually working only on one parameter, traffic indication map. But stumbling upon this particular table gave me a lot of fields. We'll come to know what exactly is meant when we say like these are fields of interest. So I have been telling since the beginning of talk, like we are more interested in broadcast frames. So why exactly broadcast frames? Reasons are pretty simple. In layman language, we can say broadcast frames are meant for everybody, right? So I need not particularly spearhead my attack to a very specific person or spearhead my effort to a very specific person. It would be addressed to everybody. Second thing, these frames are available in ample amount. So suppose I am sending such frames in one corporate network, and there is some detection mechanism already in place, very thick UTM and whatnot. Nobody will put a suspicion on this particular set of traffic, like why there are 2 million beacon frames in my local radio periphery, right? Because beacon frames are meant to advertise a network. And the rate of injection of these particular beacon frame, again, varies depending upon the device you're using, is around like per 100 millisecond, you can find one beacon frame injection in the local radio periphery, right? Yes. One more aspect. When they are more in number, then you can send more data. How? We will come to know. Issues. Deep packet inspection firewalls will still be able to find something fishy is ongoing. That seldom happens, but yes, there is a possibility. Reordering the data at receiver end could be an issue should sequencing is not taken care of before shoving the data in. Means what? If you're aware of something called as noises or other lossy mediums, there are many ways a signal may get lost, right? And if you are trying to send certain data using this particular method on covert channel per se, there might be a possibility that particular frame got dropped, or not dropped, honestly, not dropped. The signal or the baseband of that particular frame has got so low that it could not be basically interpreted from the rest of the noise, we can say. So what? This thing is still not supported, at least by my efforts as of now. No retrieval of lost frames, yes, we have discussed. SCAPI doesn't support beacon injection swiftly still. Yes, we have still been struggling. You will not believe, just before coming here, or rather when I was sitting back there, we still have been working on the same thing. SCAPI has got some issue about the buffer allocation when we try to inject certain frames on wireless. Wireless is one of least, not exactly least, but not heavily supported, we can say, data link layer on SCAPI, I would say. Darwin details. Now here comes the juicy part. Readable? Okay. So, I said my slides are messed up. So something has changed. Every alignment here. So forget about part before this. So from scapi.all import asterisk. That's fine, right? I'm trying to explain you whole script. Okay. So tomorrow when you are trying to experiment something with this, you will be having already a road laid ahead, or rather some background done on this, right? You need not rework on this. So then there is a radio tap. We will discuss about radio tap. Oh, okay, forget about, we'll discuss right now. Radio tap is nothing but that particular layer which allows your data to speak from user space to kernel space and vice versa. So this is where you can say there are certain exchange of privileged instructions happen. Okay. Details, this is actually kind of, we can say, huge topic to study. There is no formal standard assigned to this, but when we talk about injection, frame injection and wireless sniffing, radio tap plays very important role, and they have got a specific resource available on internet that is not handy right now here, but I'll reference you. If somebody needs to study that, let me know, I'll tell you. So you can go to that particular reference. They have got tons of documents explaining how radio tap works and what exactly is involved in that, what kind of data structures they have and everything. So that is radio tap. Now comes next layer, that is .11. Here, first time, our machine understands whatever frame that is coming inside our network interface card, that yes, this is wireless frame. About this address field, don't worry, I'll tell you. Then .11 beacon. This is next layer in the same frame, telling our wireless network interface card that yes, this is beacon frame. So far we were only knowing that this is wireless frame. Now we know that is wireless beacon frame it is. Then there comes .11 ELT. ELT actually stands for information element. So now our computer understands, or our wireless network interface card understands, that this is wireless beacon frame, and the layer I'm trying to read here is information element layer. This is pretty important because the traffic that we are going to do using this particular information element. And then there is a sendp. Sendp is nothing but, we can say, a command used in SCAPI to inject certain frame on layer 2, that is on data link layer. In sendp, you can see there is something called as iFace. iFace is nothing but interface. We'll come to know about, we'll come to interface in short while. And then yes, that is how it is. Now, before going further into this lower part where my cursor is moving as of now, you can see .11 ELT. In that there is ID equal to 36, comma info equal to, in double quotation marks, there is something demo, right? So this is a juicy part. We'll come to know that. We'll come to this soon. Yes, explanation. What I was trying to explain you earlier, same thing here it is. So the .11 header represents the management layer specific to IEEE 802.11, sorry, IEEE 802.11, we need to define the sender and receiver addresses in this layer itself. Yes. So ADDR1, ADDR2, ADDR3. ADDR1 is the address of sender. Address here refers to MAC address. Okay, ADDR2 is address of the receiver, the immediate receiver. So in this scenario, it would be address of the access point. But we'll come later. And third, address 3. Now this address is nothing but that particular address when you actually want to speak somebody who is not into your local access points radio periphery, but is beyond that. Something called as ESSID. Have anybody heard this word before? Extended Service Set Identifier. I'll explain you this scenario simply. You have an access point named as maybe a Holiday Inn, okay, which is here. Maybe that speaker is an access point. Beyond that speaker, say at 600 meters, there is another access point having same SSID called as Holiday Inn. Okay. Now, if I want to speak to that particular access point, which is 600 meters beyond this particular access point, then usually this address 3 comes in picture, where we try to put MAC address of that particular access point, that is Extended Service Set Identifier, and we try to communicate to that particular device. Fair enough so far? Everybody's with me? But I've told you, we'll come to the but. We've crafted frame with address 1, address 2, address 3 with all F. When your MAC address contains all F, it is nothing but a broadcast address. Everybody is allowed to consume this frame. Everybody is allowed to read this frame. Now, why all F? You might see this slide is kind of redundant, but it is not. You just got to read the header. We were trying to reach everybody in the local radio periphery and beyond it, right? So that is the reason. To reach everybody in local radio periphery, we need to broadcast our traffic in local radio periphery. So the receiver's address was made all F. Again, we wanted to reach everybody into the Extended Service Set Identifier's local radio periphery. So we made address 3 as all F. Fair enough? That is it. Now, I don't know if this is readable. Is it? Please forgive me for this. I'll share every slide and I'll explain you everything. Don't worry. So again, here the same things are explained, like SendP, iFace and everything. One more thing about iFace. Yes. Usually, by design, our wireless network interface card is operating in a mode where we cannot read or inject specific frames anywhere. Okay, we cannot read every frame and we cannot craft a frame in runtime and cannot inject it. Okay, to do that we use monitor mode, right? So here iFace actually represents the name of that particular interface's monitor mode in our system. So here you can see it would be either MON0 or WLAN0 MON. So there are actually two ways we can say. First thing, when it was older set of aircrack NG tool, there it was AirMon they used. They had some conflicting issues, or rather they had something which was messing up into some Realtek devices, taking down the MON0 in the transit. It was not basically running it for longer time. So that was issue. To overcome that, there came another improvisation. They call it as a zero chaos. So for some time, like a couple of years back, for 6 months, they have ran another tool in parallel with AirMon NG. There was AirMon ZC, that was zero chaos. If you're using Kali Linux, then there is no problem at all. But if you're using Aircrack into Ubuntu, then yes, you can find these two tools there. Okay, so in case of latest Aircrack NG on Kali Linux, you can see it is WLAN0 MON. In case of Ubuntu, Aircrack AirMon NG, it will be MON0. In case of Ubuntu, AirMon ZC, it will be WLAN0 MON. Fair enough? it might look little chaotic as of now, but it is not. So yes, ongoing work. I just striked it a few minutes back. So we got handle. Now everybody would be asking, like, where is demo coming after a couple of slides? That's it. Okay, and we'll be in time. Right. So while particularly running this kind of communication channel over some broadcast medium, there was an issue. How you would identify one person who is trying to broadcast something, but there is no identity in place? Like in the trivial chat rooms, we have some handle, right? We've been trying to solve this question on sockets layer, but then we missed obvious. We missed common sense. What all we did is, like, we just defined a variable, and we have imported that variable in the layers that we have seen earlier. Okay. That particular set of code is pretty messy, so give me some time, like maybe in a couple of days or maximum in 1 week, I'll have that thing code uploaded on GitHub where you can access it, and I'll tweet that thing. So whosoever is interested will be able to run that code on their laptops as of now. Thoughts towards semi-managed approach. Now somebody might start feel fishy about this, like, why semi-managed approach? Obviously, if I'm managing a network, I need to know what's happening inside my network. Being a broadcast frame, in most of the scenarios, we do not monitor broadcast frames, right? So is the reason semi-managed approach. What kind of strings have been passed or something, we can put some maybe learning algorithms on that and can get intelligence on the top of that. Could be anything, right? So yes, so that in coming times we can take care of sequencing more realistically. Sequencing is like huge topic, and there are like at least a couple of dozens thoughts I have already in mind. We can discuss that offline, because somebody there is trying to say me like 2 minutes. Before proceeding further, before going Rahul, can you come up? We got to show you demo. Remove this. This is working VGA. Copy that. Readable? Nothing? Okay. Meanwhile, I'll increase the font. Perfect. Yeah. Readable? Screen is readable? Not so far? Any? Okay. Okay. Hey. HDMI है यहाँ पे होगा ये है ना HDMI लिखा है okay. Spare me a couple of moments. I just am trying to arrange the demo. चल रहा है? It's okay, right? दोनों चल रहे हैं ना? नहीं, लाऊ ना गरज नहीं. Now I just hope, gentlemen just pulled out my network interface card, hope it will work. Let's all succumb to, or rather pray to the demo gods. Perfect. Input handle, identity. So say Darwin. Darwin is entering something, maybe all is alpha. It didn't work. I'll show you demo offline. I have got some time constraints. Huh? Just change it to 1. Just a second. Yes, do that. Center has to be more than here. Yeah. Copy. Now. That is I. No. Check kare. 1. Yes. Put in. So yeah, we're putting in handle Darwin. Okay, Darwin couldn't. Okay, so let's all is alpha, and let's see what's happening here. So this was a receiver which was receiving everything on particular broadcast frame, and my message was, all is alpha. We still can say maybe all is Charlie, all is Charlie. Just because the other interface was pulled out, I could not show you reception on another interface. Otherwise, this is also possible. Fair enough? Demo you might see like this is pretty small demo, but involves a lot of things and messes up big time. Now just a couple of slides remaining and that's it. I won't try to check your patience anymore. Yeah. Now visible. Oh, yeah. Visible? Perfect. So acknowledgement. Yes. A huge thanks to Nalcon for allowing me sharing my understanding. I will not call it research. Research is way ahead. Vivek Ramchandran for his excellent primer on wireless security. It was Clubhack 2010. He distributed his DVDs and I was fortunate enough to receive one. Rahul Binjwe. It was CoCon 2017 and I was actually discussing covert wireless networks there. And Rahul, one of my colleague by then, he came up with a question. What is a use case? And use case is Darwin here. Rahul Gupta for helping me big time into messing up into Python, internals of Python per se. My family and everybody who helped me in some or other way. So that is all. Exit 0, hopefully, if everything is conveyed in appropriate way. These are my contact details. You can approach me. And most of the times, if I know answer, I'll try answering. If I don't know answer, at least I'll divert you to some resource or some person who knows the answer. So that is all on my part. If you have any questions or many questions, I'll be happy to answer them all. Yes?
Or send the data for that matter. Uh, I'm not able to understand it properly.
Okay. So this is typical beacon frame, you can say. Okay. Except I did not mention the ID specific to the SSID. Okay. So in this beacon frame, the .11 ELT layer, if you see, okay, has got some number, that is 36. Okay. So ID field represents a number, and that number has got some functionality or some significance to serve into the information space of that particular ID. Okay. So this particular information space, in case of ID 36, ID 221, ID 226, ID 256, or rather the list is pretty huge. It's somewhere around 250 bytes and beyond. Okay. If any one of you is an exploit developer, he would really recognize importance of 250 bytes, right? That is one thing. So in this particular info field of that particular ID, so the ID would be having number, that number would be mapped with a string. So instead of that particular legitimate string, I'm sending my data over it. And I'm reading that particular information element's ID field and the mapping of that ID field to that particular info space in my Python script. Okay. That is how I'm bypassing all raw sockets, or rather that typical AF underscore IN8 or something, 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 which requires you to declare your IP addresses and whatnot, right? So now considering this thing through a little different perspective, I can put any identity I want, and still I'll be able to communicate.
Why can't we go to the next layer and put that data in the payload that is there?
For operational overhead purpose, I don't want. Why do I need my frame to be parsed till network layer in order to understand what data it is consisting?
That is the time overhead because of that.
It is operational overhead. It could be throughput, it could be your memory, it could be anything, right? And you never know what kind of cache is involved, buffer cache is involved in order to facilitate these all set of activities to you, right?
Okay. Thank you.
Thank you. Any other question? Yes.
So, hello. Yeah, I'm not sure if I missed, but how are you actually differentiating between actual beacon frames that are, legit and the ones that you're sending with your data? I mean,
Excellent question. You see the information element with specific element ID? That element ID is not very commonly observed. There is possibility of collision, no doubt, right? But ID 36, I have not seen commonly present in my local radio periphery. I'm using that ID.
so this ID is for different kind of parameters, is it?
Yes.
ID 36.
That particular ID is mapped with a specific significant operation, or rather significant information, we can say.
And this one is not used in standard.
Not frequently used. It is used. This is part of specification. I have shown you the table. If you want me to revisit. This one, information element ID table. I have picked element IDs from this table. Initially, I was stuck upon traffic indication map, but then I found many such places where element ID is mapped with some space which is more than I think 100 to 200 bytes. That was fair enough space for me to at least ship my text or string over it.
Okay, thanks.
Clarified? Okay. Any other question? All right. Then, at last but not the least, I thank you all for being such a very nice audience. Thank you very much.